Today's warm-up problems are on creating and using linear regression equations. Number one asks us to use our graphing calculator. We want to find the line, not the line of best the line of best fit. For the data in the table below, find the value of the correlation coefficient and then use that to make a prediction. Notice it tells us to use T to represent the number of years past 1990. So our first list, our values are not going to be 1998, 1999, 2000, 2001, and so on. Instead, our X's, or our T values, 1998 is 8 years past 1990, so we're going to enter 8 for that and 9 for 99 and so on. So these should be your X values that are entered under list 1. So to enter your data into your calculator, you want to go to Stat, which is on the right here, Statistics, go to number 1, Edit. And I have entered my data here already because nobody wants to see me do that, although that's a typo. What's that one? 1471. So you would enter all of your data. Notice I have my X's, my T values under list 1. I have the number of tickets sold measured in millions under list 2. In order to draw the scatter plot, it doesn't ask for it, but it's good to see. Once I enter my data, if I push graph, I don't see anything. There's 2 reasons that may be the case. First of all, make sure your stat plot is on. Stat plot is up here in blue. Unless it's been turned off for some reason, it should still be on from when we did this in class last time. Notice plot 1 I have off. I'm going to turn it on. Pushing graph, I still see nothing because my data is not in between -10 and +10 on both the X's and the Y's. To zoom into your statistics, you go to zoom and then you go to number 9, which is zoom stat. And I see my data there. To create the linear regression equation, you go to stat, you go over one time to calculate, and it's number 4, linear regression equation. I am going to store my regression equation under Y1. To do that, you push alpha trace, and I want to store it under Y1. And that's going to take the regression equation, go to Y equals, and it's going to type the entire equation in there for you so it graphs the line. So our regression equation doesn't tell us how many decimals to round to. So I've got Y equals 19.309x. It does tell us to use T, so we probably should. 19.309t plus 1214.836. That is our regression equation. Next thing it asks for is for the correlation coefficient. Yours probably gave it to you when you ran your regression equation. Mine did not because my stat diagnostics are not on. If you ever don't see the R value and you need it to turn your stat diagnostics on, we go to mode. We scroll all the way down to the second page. If you have a color calculator, I think it's on the first page, but you go to stat diagnostics and right there you turn them on. Push enter on. And then run your regression equation again. You can either go back to stat, calculate, and so on, or because the last thing I did was run my regression equation, I can just push enter and it'll do it again. And notice now it not only gives me that A and B value, but it gives me R squared, which isn't terribly important, at least not yet. And it also gives me R. R is, I think it was 0.989. It doesn't ask us to interpret that, but because it's a positive number, we know we have a positive correlation. And because it's very close to 1, it is a very strong positive correlation. And notice looking at my curve here, notice that line, all the points are very close to that line. Last thing it asks us to do is to predict the number of movie tickets sold in the year 2014. 2014 would be 24 years past 1990. That would match up with t equals 24. So we're just going to go to our regression equation and plug in 24. And there's a couple ways you could do it. You could actually just go back to the main screen and type in 24 for time. The problem with that sometimes is that this is a rounded number and this is a rounded number. And if we need our answer to be accurate to 3 decimal places, it doesn't say we need it to be, but your answer might be off by just a little bit because we've rounded those numbers. So another way you could do it, and this only works if you stored your regression equation under y equals. So when we ran our regression equation, remember we stored our regression equation under y1. But now I can look at my table. So to get to table, you push second graph, and I want my t to be 24. And it'll give me the y value that matches up with a t value of 24. You can push down a bunch of times, down, 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 until you get to 24. Or another way you could do it, if you need to get to 124, you wouldn't want to do that. Another way you could get to 24 quickly is to go to table set right here, which is second window. And it asks you where you want your table to start at. Well, we want our table to start at 24, and now it's going to start right at 24. Delta table, triangle in math is delta. It's the Greek letter delta. That's how much you want it to change by. So right now, if I'm starting my table at 24 and my delta table is 1, the x values are going to be 24, 25, 26, 27, and so on. So now when I look at my table, now it starts at 24. So 1,000, or I guess these are in millions, so what would that be? 1,678.3 million tickets sold. If you need more decimals than it gives you here, maybe it says to round to 3 decimals. Well, it only gave me 1. If you highlight the value, it gives you way more decimals down here. Since these are all rounded to the nearest whole number, we should probably round our answer to the same. So 1,678 million tickets sold. That's a lot of tickets. Number 2, similar problem, different setup. It says a bucket is full of water, begins leaking. The bucket's volume is measured at different times. It gives us the time measured in minutes as well as the volume of water that is in the bucket measured in liters on our table here. And then asks us similar questions. It wants us to find the linear regression equation, report the R value, and then make a prediction. So we need to enter our new data, so we go to Stat Edit. To get rid of the old data set, we're going to highlight list 1 and then push Clear, Enter, and it'll get rid of the old data. Highlight list 2 and do the same thing. Clear, Enter, whoops. Clear, Enter, and all my data is gone. So now we can enter our new data. Create our regression equation. Again, I'm going to store my regression equation under y1. And that will give us our answer to parts A and B. Write the linear regression equation. It tells you to round to 3 decimals, round to the nearest thousandth. Y equals negative 0.679. X plus 10.714. Report the R value. R is negative 0.991. What does it tell us about the data set? It tells us 2 things. We have a negative correlation, and it is a very strong correlation. Again, we could take a look at our scatter plot with the line of best fit in there. All the points are pretty close to the line. Makes sense that it's a strong correlation. Slope is negative. Makes sense that it has a negative correlation. How much water would be in the bucket after 12.5 minutes? Our answer needs to be correct to the nearest thousandth. So when we plug in 12.5 here, because we've rounded these numbers again, that answer might be off by a little bit. So you either need to write down more decimals from the regression equation, maybe 5 or 6, and then plug it into that. That would work. Or again, you can look at your table, and again, we go to second table. Notice 12.5 is not on my table. It gives me 12 and 13, but doesn't give me 12.5. So again, you want to set up your table. Table set, second window. I'm just going to start it at 12.5. That would work. Or you could change your delta table to 0.5, and then it'd give you 11, 11.5, 12, 12.5, and so on. I'm just going to start mine at 12.5. And now when we look at our table, looks like it has 2.232. Make sure you include units on there. Volume, our Y value is measured in liters.